Now let's derive an equation for your kinetic energy. So the whole thing is about movement, right? So we'll consider an object which is already moving. It's moving with a velocity of u. After some time, we'll start applying a force of F, right? So this we'll consider as time t is equal to 0 seconds. So what will happen to the object? Obviously, since we are acting in the direction of the motion itself, what happens? It will speed up. Agree? So let that velocity be equal to v and time be equal to t seconds later. So with all of this, the object has moved a distance of s. It got displaced with to a distance of s meters. Okay guys, you understood the setup? Now, what is that we are looking at? We are looking at getting an expression for work, right? It's always work. Why? See, the funda is quite simple. If I get an expression for work that is done by this force, right? So let me make that clear. Work done by the force. If I am able to get the work done by the force, we already know this funda. Whatever work we are doing, if there is no other exchange of energy, frictions and all of that, if that is not there, all of that purely gets converted to energy. And energy that we spent is used as work, right? You know this funda. So based on this, we can get an expression for the kinetic energy. Got it, guys? So what is work? Same formula, force into displacement. What is force? Force is nothing but mass into acceleration into displacement s. How do we go across this now? See, we have to get expression in terms of movement. Acceleration is related to movement. Displacement is also related to movement. How else? Well, I want in terms of mass, which we already have, and also velocities, not acceleration and displacement. How can I relate acceleration, displacement to velocities? Where will we get an expression wherein we are talking about acceleration, displacement and velocities? Where do we get this expression and equation? Yes, equations of motion. So which equation are we looking at? Can you pick one? Yes, the second one, is it not? V, U and S comes and A also comes in this particular equation. So we have V square is equal to U square plus 2S. All we need to do is now arrange. So we have V square minus U square divided by 2. All this is simple maths. If you're not able to understand this, please watch solving linear equation in one variable. Okay. Right, now coming back, I have an expression now. Let me substitute it over here. Substituting above in 1. So we have W is equal to mass into acceleration. In place of acceleration and displacement, we have V square minus U square divided by 2. And we have an expression. So if I use distributive property, let me show it this way so that you guys understand. What does distributive property tell? M divided by 2 has to be multiplied with V square and also minus U square. And so we have M by 2 V square minus M by 2 U square. Okay. And all of this as per this funda, law of conservation of energy, all of this has to be converted to an energy, and that energy is your kinetic energy. That's it. It's your expression. So remember, right, this funda basically. Everything else is quite simple. The same thing. Diagram is quite simple. This expression is also quite simple because we have been using work is equal to force into displacement, and we know what is force. You are already familiar. The most famous equation. Right. After that, another set of most famous equations, equation of motion. We already used it a lot of times. Get an expression for E and S. Substitute and you get the answer. Okay. So there are different cases we'll be talking about in the next set of slides. So now we'll be looking at deriving or writing things for your exams. Actually, this is good enough, but still I want to put it in a better manner. Let's derive an expression for your kinetic energy. The initial assumption is we're going to consider an object of mass m, which we already done. The diagram is done. This is of mass m moving with the uniform velocity of u. Let it be displaced through a distance of s when a constant force F acts on it in the direction of displacement. Done. Let its velocity change from u to v. Okay. Let a be the acceleration produced by it. Done. This is your diagram. The work done by the force would be equal to work is equal to force into displacement. But we know that force is mass into acceleration. Okay, agree? Let me write it here itself. Mass into acceleration into displacement as because, not this. This is not because, I guess. Yeah, because. This is because, right? Force is equal to mass into acceleration. That we are substituting. Now, we have to get an expression for acceleration and displacement. So, as per the equation of motion, we have v square is equal to u square plus 2as. And now rearranging and everything, we have v square minus u square, whole thing divided by 2 is equal to a into s. And we're going to substitute this in 1. So let's substitute a into s in acceleration and displacement in equation 1. And so we have w, which is equal to mass into acceleration displacement, that is v square minus u square divided by 2. Okay, so we have w is equal to half mv square minus half mu square. Okay, now the energy part. The object gains energy equal to the work done on it. This is as per the law of conservation of energy, right? As per your syllabus, we just need to learn two more expressions. I am just summarizing basically. When the object has the initial velocity of u, your kinetic energy would be half mv square minus half mu square. Right, same expression copied over here. And the second case will be when the object starts with the initial velocity of 0. If this becomes 0, what happens? 0 into anything is 0. So we have the kinetic energy is equal to half m. What is the velocity? Whatever the velocity is there at that moment of time, that is the square of that. Okay, that would be your expression for kinetic energy. Most of the times we use this only, but the funda is that we got it from here. So keep all of this in mind. Learn it systematically. So if you guys want to copy something from here or take a screenshot or something so that you guys can have a look at it one go. Anyways, this is what you have to write in your exam. You can't miss this. The same thing, just that it's well structured.